All right, so let's go back to the 10-2. So we were talking about the more versus less situation in the last video. And we found out that with the more situation, all the letters were different. And so we had 4 options for the first letter, then 3 choices, then 2, then 1, and that gave us 24 distinct arrangements. All right, that idea, that having to multiply 4, then 3, then 2, then 1, that's going to come up a lot. And it turns out that there's an operation, like you haven't seen it in a arithmetic class, but there's an operation, a symbol that tells somebody to do that. So if I wanted you to do that, what I could do is write 4 and put an exclamation part, and it means 4 times 3 times 2 times 1, and it's called a factorial, 4 factorial. Okay, so let's take a look at that idea here. So the factorial formula. So if you have some counting number like 4, then 4 so if you have a counting number like 4, then 4 factorial would mean this. 4 factorial would mean start with 4, then multiply it by 1 less than that number times 1 less than that number until you get all the way down to 1. So 4 factorial would be 4 times 3 times 2 times 1 would be 24. Okay? Now, 0 factorial sometimes happens, and when that happens, it's defined to be 1. You can't think of it that way. You just have to know that the definition for it will be 1. All right, so with the more situation we had, that one, there were 4 letters. That's the one where we could have used that idea, because 4 times 3 times 2 times 1 is just 4 factorial. So that would wind up giving us the 24 that we found. All right, so that works. That works as long as the objects that we're arranging, in this case I'm using an example with 4 different letters, as long as those are all different. But if the objects we're arranging are like L-E-S-S, where you have 2 letters are lookalikes, right, S and S, that means some of your arrangements won't really be different, okay? They'll look the same. And we talked about that, like having an L-E-S-1, S2 looks the same as L-E-S2, S1, so you'd only want to count it as 1 arrangement, not 2, okay? All right, so if you have n objects, again, in this case, it's still 4 objects. So if you have 4 objects, okay, and you want to know how many distinct or distinguishable arrangements of those 4 objects you could make, but you have lookalikes, then you have to watch out, because you'd have to take that 4 factorial that you have, and you'd have to divide it by the number of ways you could arrange, in this case, 2 letters. I'd have to divide it by the number of ways I could arrange an S, 2 S's. So they could be that way or they could be that way. So there's 2 arrangements, okay? All right, so that would wind up being the same as me doing 2 factorial. So this turns out to be 4 times 3 times 2 times 1, but then I have to divide by 2 times 1. That's going to be 24 divided by 2, and that's going to give me 12 as my final answer. The number of distinct arrangements in the word less would have been 12. The number of distinct arrangements in the word more would have been 24. Okay? So let me now go back, now that I've talked about what a factorial is. I can help you see this a little bit better. All right, so on this one, the problem is that you've got the letter A occurring twice. So there's, 2 ways you could have arranged two ways you could arrange those 2 letters. And then let me just continue this. If I arranged the 3 T's, okay, then I could have done a bunch of different things. I could have done 1, 2, 3 or 2, 1, 3. I could have done 1, 3, 2, or I could have done 3, 1, 2. Okay, Or I could have done T1. Nope. Let's see. I'm trying to make sure I'm getting all the different ones. Or I could have done a T2, then a T3, then a T1. Or I could have done a T3, then a T2, and then a T1. Okay, and so then there's 6. If I actually work it out, there's 6 different ways you could arrange 3 letters. Okay, so here there were 2 ways to arrange 2 letters, 6 ways to arrange 3. So really what it is, if the A occurs twice, okay, then 2 factorial is what you should, then we're going to be using 2 factorial to knock out the fact that there would be lookalikes. And then since 3 occurs, since the A occurs twice, the T occurs 3 times, then we're going to use 3 factorial to knock out the lookalikes there. And 3 factorial would be 3 times 2 times 1 and give us this 6 that we're getting here. 2 factorial is 2 times 1, gives us the 2. So here's what you do if you have lookalikes. You're going to wind up using this formula, where the top number is how many objects you're arranging, and then the bottom number, the denominator, you're going to wind up dividing the top number by how many ways you can arrange, how many, let me just show you. I'm having trouble saying it so it makes sense. So let me just show it. So like here, there's 7 different letters. So there's 7 objects. So that would mean, according to that formula, I should have 7 factorial on top. Then I'm going to divide by 2 factorial because of the letter A occurring twice, and 3 factorial because of the letter T occurring 3 times. Okay? So the 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1 all the way down. 2 factorial would be 2 times 1. 3 factorial would be 3 times 2 times 1. And this is all multiplication, so if we have any common factors, top and bottom, we'll be able to cancel them out. So like the 1, the 2, and the 3 would cancel. I also could divide 2 into 4. And then I could finish it up if I wanted to by multiplying the remaining things, the 7 times 6 times 5 times 2. So that would be 42 times 10, or 420. All right. Turns out there's going to be a button on our calculators that we're going to be able to use to do this. And so we won't have to do so much of this right here. And I'll show you that when we get to class. I'll have everybody have their calculator so we can do it. So let's go ahead and just look at what the factorial really means and how to do it without using the calculator. So we already know this one. It means 4 times 3 times 2 times 1. So that's 12 times 2 is 24 times 1 would be 24. Now, what's kind of fun is if you had something like 9 factorial over 7 factorial. What winds up happening there is the numerator is 9 times 8 times 7 times 6, right? All the way down to a 1. So think about it, 6 times 5 times 4, all the way down to a 1. And then the denominator is 7 times 6 times 5, all the way down to a 1. And because it's multiplication, 7 over 7, 6 over 6, all of these can cancel out, can't they? So all of that cancels, and the answer to this question turns out to be just 72. Okay? Right? Then question number 3, we could do a similar thing. The numerator would be 50 times 49 times 48 times 47 times 46, right? All the way down to a 1. In the denominator, I'd have 48 times 47 all the way down to a 1, and then 2 times 1. So from 48 to 1, I could knock that out. And then I'd have 50 times 49 over 2. Now when I say without a calculator, I really mean without using the factorial key. So you could use your calculator at this point and do the 50 times the 49. divided by 2, okay, because that's kind of too much to really be able to figure out without a calculator, okay. So it wouldn't be, I don't mean you can't use a calculator to do that. And so you'd wind up getting, when you're finished, 1,225 on that one, okay. And then this one, which will come up once you know more about how we're using it, this one would be 8 factorial over 6 factorial, 2 factorial. So the 8 factorial means 8 times 7 times 6 times 5 all the way down to 1. This means 6 times 5 times 4 all the way down to 1, and then 2 times 1. So from 6 down, I could knock that out. And then I'd have 8 times 7 divided by 2, 56 divided by 2, that would turn out to be 28. So I can evaluate a lot of these expressions without a calculator, but it's going to turn out that there's going to be a button on your calculator that you can use to evaluate these, okay? And so we're going to learn about that. I'm going to show you where that is when you come to class on Monday. I'm just going to show you where to find that factorial button when you come to class on Monday, okay? All right, let me go ahead in this same video and finish question number 9 while we're at it. Tricia is taking 13 preschoolers to the park. How many ways can the children line up in single file to board the van? Okay, well, first person in line, there's 13 kids to choose from, but then the next place in line, there'd only be 12. Then the next place in line, it could be one of 11. All the way down, right, until I get to just 1 there at the end. So it's 13 times 12 times 11 times 10 all the way down, which is the same as 13 factorial. And so on Monday, I'm going to show you where that factorial key is. And you can actually then type that in and find out what the answer is going to be.